Hey everybody, this is Jordan from Web Developer Training. Today I want to talk a little bit about security. So I want to go over with all of you the security audit that I have created. Now I'm not like a credentialed security expert or anything, but I've put a lot of time and effort into coming up with an audit that I feel is relatively thorough and that should hopefully help catch glaring, obvious security vulnerabilities. So let's jump right in and let's do it. First off, I think you should perform this audit about once per quarter. I think every 3 months is a good amount of time to at least review this and to try to implement some of these things. Individual line items you might decide don't need to be done as often, but as a general rule, that's what I'm thinking of doing. So first, I recommend just going to the latest OWASP top 10. So essentially OWASP is an organization. Hold on, I need to look up what it stands for again. The Open Web Application Security Project. An online community that produces freely available articles, methodologies, documentation, tools, and technologies in the field of web application security. So they seem pretty legitimate. From my research, they seem like a pretty awesome organization. They publish this report every few years, and it tells you the top 10 vulnerabilities that they have found. So I feel like it is a very good thing just to start off, find out what the latest vulnerabilities are, and make sure that you are protecting yourself against them. So by 2017, the top 10 are now injection. So that will be things like SQL injection, but there are other types of injection attacks, as far as I know. And what you can do to defend against SQL injection is to make sure you use a good library that will sanitize your input. And if you're not using a good library or using some kind of technology that's not SQL, look up the specific mitigations for injection attacks for those other technologies. But essentially, you need to sanitize input. Next is broken authentication. So when you're building your authentication and your authorization system, you need to put a lot of time and effort into making sure that the authentication is very strong, is up to date, and doesn't have any glaring obvious flaws. So make sure that you're using cookies appropriately. Make sure that you're using JSON web tokens appropriately or session tokens appropriately. Make sure that you're using web storage appropriately. And building an authentication system obviously could be a whole another video or set of videos, but you need to make sure that everything, the authorization and the permissions and the integrity of your data essentially is built on top of a strong authentication system. So if that's broken, then everything else kind of doesn't matter. Sensitive data exposure. So obviously you need to have strong authentication so that you can have strong authorization, which is essentially permissions, so that you don't expose data to people who aren't supposed to see the data. XML external entities. I'm actually not sure what that is. I don't deal with XML that much, so I guess I haven't really looked into it. What I probably should, to make sure that my stuff is not vulnerable to it. But I think I did look into it, and it wasn't a big deal for what I was doing. Broken access control. So I believe that is just like what I talked about, is permissions. So make sure that your authorization is strong as well once you have strong authentication. Security misconfiguration. Generally you need to go over your systems and make sure everything is properly configured. And we'll dive into that a little bit more in the security audit. Cross-site scripting is a big one that there's a ton of information on the internet about how to mitigate cross-site scripting attacks. Essentially, though, you want to make sure that any third-party data, so with web applications, any third-party HTML or CSS or JavaScript, stuff that you don't own and control, you need to make sure that you sanitize it so that people can't just run arbitrary scripts on your website. So you can sanitize it, or you can sandbox it, putting it in iframes with certain attributes. There's a few things that you can do there. Then insecure deserialization. So essentially that's taking something that is a string and converting it into something that's usable in your app. So you got to make sure that you do that appropriately. Probably use a secure library to do that. Using components with known vulnerabilities. So you should make sure that all your dependencies are up to date as much as possible and that they don't have any vulnerabilities that have been reported. So usually if you keep your stuff up to date, the reason that there are new patch versions to software is because there are known vulnerabilities that are being patched. And then insufficient logging and monitoring. So you want to know when you're being attacked. You want to know when there has been a breach. Okay, so that's the OWASP top 10. I would use that as a guide. Make sure that you can confidently address every single point in this OWASP top 10. Okay, so let's continue. So yeah, once you've done the OWASP top 10, there's a few awesome tools here that will essentially run automatic checks or automatic audits on your websites for you and catch some obvious flaws. So here is a website or a web application that I've been building called Podcrypt. Essentially, it's a podcast application that lets you donate. So I'm going to use it as an example. So let me copy the URL. So let's throw this into the Mozilla Observatory. Okay. So it's the first time I've run this scan on this site. So I get a D+. So you can see there's a lot of things that I just haven't implemented yet. I don't have a content security policy yet. So I get a big hit. Luckily, my site doesn't really use cookies, so don't need to worry about that. Let's see. A lot of this is I don't have any headers, any of the security headers that I should. So it should be relatively easy to get this to A or an A+ even. And what's nice here is that it gives you a little recommendation of what is a good next step. So they're saying go ahead and add the X-Frame options header and at least create a content security policy with the frame ancestors directive. So, and once I implement that and run the scan again, it's going to tell me what the next step is. So it's very nice, very intuitive. So this is Google's CSP evaluator. So essentially, it will look at your website. Well, you don't put your website in, you put a content security policy in, and it will tell you if it's safe or not, essentially. Yeah. None of these things are going to be 100%, but it's going to be pretty good. I don't even have a content security policy yet, so I'm not going to put that in. And essentially what a content security policy is inside of your website, you will either create a meta element or you'll return a header that describes essentially which domains are allowed to load scripts, execute scripts, load styles, execute styles, load frames, iframes, stuff like that. So it's really locking down, and it's really there to help mitigate cross-site scripting attacks. So make sure that when you do create your CSP, you go ahead and run it through this evaluator. And then this one will check the headers that are returned for this URL. And I get a D here. So yeah, there's a bunch of headers that I just haven't implemented yet. So these are cool tools, and you can run them anytime on your site. So I'd love to get an A there. When I do have a CSP, I'd love this to return tons of green, and I'd love this to be an A as well. So run your site through those tools. That'll be awesome. Okay, next. Ensure encryption of data in transit. Let me zoom in just in case you can't see this super well. So essentially, you want to make sure that everything is being run over a secure connection, that all of your data is end-to-end encrypted. That means from the client's device all the way to the server, you want that. You want when the data is traveling from the client to the server, that data should be encrypted, and man-in-the-middle attacks should really not be possible if you're using SSL. So if things are running over HTTPS, or if you're using WebSockets, you want to run the WebSockets over SSL. Everything needs to be SSL. So if you're using like a Postgres database, there are some settings where you can force any connection to the database to be over SSL. There is also a content security policy directive that can make sure that no resources are loaded over SSL, or you can upgrade any insecure requests. So make sure everywhere possible, everything is loading over secure sockets. Okay, ensure encryption of data at rest. So essentially when data is in transit, that means it's moving from one machine to another. Once it gets to the other machine, though, it's going to be unencrypted. So obviously data right now, for example, all the data you're seeing is unencrypted. If I type a credit card number or a password into a form on this page, it's not encrypted while I'm typing it. Also, once it hits the server that it's going to, it's generally not going to be encrypted once it hits the server. So if I'm giving, let's say I have users and they're sending passwords down, or credit cards, or just personal information, any kind of sensitive data to my server, it's going to be unencrypted in memory, and then I'm going to save it to my database, most likely. That's called being at rest. Wherever you store the data for it to be persisted, essentially, if it's not in memory, if it's not in random access memory anymore, you should really be encrypting it. So essentially that means if you have a database, encrypt the database. So you'll have essentially some kind of key, some kind of secret that you'll need to then custody. And that key is used to encrypt data coming into the database and encrypt data going out. So that means that an attacker would have to compromise the database and the key. And if those both are stored, on physically separate systems, somehow, if you can get that to be set up right, you can make it harder for that data to actually be compromised. So databases, hard drives, passwords, that's very common practice, is that you hash your password. So essentially it's an encrypted version of the password in a way, right? And you store that in the database so that a clear text password is never stored. So just think about it. Anything at rest, if possible, should be encrypted. Now next, you should update all dependencies. So if you're using NPM, every single dependency should be on an up-to-date version. Any servers that you're using, if you're using like a Linux server, if you're using an Ubuntu server, sudo apt-get update, sudo apt-get upgrade, make sure everything is up to date as much as possible. And then even the OS version itself, you want to make sure that you're on an LTS version of Node.js or Ubuntu, something that is receiving security updates still and is going to be maintained for the foreseeable future. Because you're going to want to do these things, and we talked about this a few minutes ago. People are finding vulnerabilities in software quite often. And so if a known vulnerability is found, you're going to want to update that. Known vulnerabilities are public, so any attacker can just look up known vulnerabilities and try to attack people who have been lazy and haven't updated their software. Another cool thing that GitHub and NPM are doing, and maybe other services as well, is they're actually automatically scanning your dependencies and your code and finding vulnerabilities. And when they find them, they'll alert you on their website or send you an email or something. So make sure if any vulnerabilities are found in your dependencies that you do something about it. Either update dependency, or who knows, they might find a vulnerability in a dependency that is already up to date. So you could go open an issue on that repo, or you could remove the dependency temporarily, or figure something out. Okay, next, you need to lock down your ports. So different protocols are going to have different ways to access the internet. The most common ones you'll probably deal with are TCP or UDP, probably just TCP. But there could be other protocols as well that have that essentially connect your machine to the outside world. So you want to make sure that you lock that down. This is a major attack vector. Only open ports that are absolutely necessary to open. So if we're talking about just a normal web application, probably port 443 is all you need to generally be open. Port 443 is for HTTPS. Port 80 you probably want to close. If possible, you do not want insecure HTTP traffic or unencrypted HTTP traffic coming to your server. So close port 80 if at all possible. Keep 443 open, and then you might need to SSH into your server. So you can open port 22, but you probably shouldn't keep it open always. Maybe figure out some kind of mechanism for only opening that port when you absolutely need it to be opened. Okay, so that's just which ports to open. Now, once a port is open to the internet, you want to restrict the set of addresses that have access to that port. So for, if your website is just generally open to the world on port 443, there's not much to do there. But you might have other components that aren't a general web server. So your database, for example, probably only needs to be accessed from your application servers. So your database should only allow your application servers' IP addresses to access them. Also, you might have load balancers. So your actual application server, if it's behind a load balancer, you only want the application server to receive traffic from the load balancer, not from the general internet. The load balancer itself would be the one that is open to every single IP address in the world, essentially. So make sure that if you open a port anywhere on any of your machines, it only is accessible by the smallest possible set of IP addresses. That just shrinks the attack vector, the attack space. Okay, we talked about this a little bit earlier. Ensure strong authentication. So you really need to study up. Find out what the best practices are for the technologies that you're using. Make sure it is up to date and secure. So generally, for our web applications on the client side, we're going to use some combination of cookies, potentially JSON web tokens or other cryptographic type tokens or random numbers, maybe some private and public keys. We're going to store this stuff potentially in web storage, so local storage, maybe session storage, IndexedDB. All these things need to be used appropriately. If you store credentials in web storage, you're now vulnerable to cross-site scripting attacks. So you need to weigh the consequences of a cross-site scripting attack. If you store credentials only in cookies, you don't necessarily need to worry about cross-site scripting attacks if you have the HTTP only flag set, because JavaScript isn't allowed to access the cookies, but now you open yourself up to CSRF attacks, cross-site request forgeries. So you need to weigh the pros and cons of where you put your authentication credentials, blah, 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 all this stuff. Make sure you come up with a very good authentication strategy. And I'll probably make a video on the strategy that I'm currently employing, and I guess I would recommend it. Or we can at least talk about the trade-offs of what I could recommend. Once you have strong authentication, oh, and by the way, authentication essentially is determining who is accessing your system. So when we talk about authentication, it's who. We want to be able to essentially prove the identity of somebody. Now, authorization is once you know who somebody is, what can that person access? Or what can, whoever it is. It might be another computer. It might be another machine or another process, right? But once you identify the entity that's trying to access your system, authorization then is what can that entity create, read, update, or delete. So what data can they access and what data can they change? You want to make sure that this is very strong. So study up on the latest authorization best practices. Depends on your technologies. If you're using a Postgres database, they have authorization built in that you might want to use. If you're doing GraphQL, you might want to move the authorization to the GraphQL layer and let Postgres just be kind of dumb. I recommend if you are using GraphQL, well, I recommend to use GraphQL, and I recommend using custom directives essentially to declaratively put your permissions into your schema, which is really nice. I highly recommend, if you do roll your own system, and potentially even if you don't, if you're using, for example, the built-in Postgres permission stuff, I recommend automated tests, because I feel like it's relatively easy to overlook something with permissions. You want to lock down access to your data. Data integrity is pretty much probably the most important thing. That's what we're trying to secure here, is access to the data. Who can read it? Who can write it? So if anything goes wrong, it's going to be very bad. So I recommend creating automated tests that you can run at any time and make sure that your permissions are doing what they're supposed to be doing. Then you need to make sure that you have physical and logical access controls. So, for example, you should teach people that they need to lock their screens. Everyone, depending on what kind of access they have, essentially. So if they don't have access to any sensitive information, it probably doesn't matter. But if they do have access to sensitive information, people should be locking their screens. People should not be sharing passwords with each other generally. A password and a username combined is somebody's credentials. That proves who they are. If people just share their passwords with each other, then you can't be sure that your authorization actually works, because your authentication is broken. If people aren't who we think they are, then the authentication is useless, essentially. Okay, so once you have strong authentication and authorization, generally, then you need to analyze every endpoint in your system. So if you're doing like a REST API, every HTTP endpoint needs to be analyzed. If you're doing a GraphQL API, you essentially only have one endpoint, but you're going to have custom queries, custom resolvers, or essentially just any query or resolver. You want to make sure that anytime a user can access data, that data is properly authenticated and properly authorized. So any process that's hooked up to TCP/IP port, you need to go through manually and audit all those. Or you might have automated tests to do this, which would be awesome as well. Look at the reads and look at the writes. Find out what should be permitted and what should not be permitted. Okay, next, rotate all keys. So you're going to have cryptographic keys. You're going to have secrets. Everyone has passwords. You should rotate these. The longer a secret exists, the more likely it is to have been compromised. So, just cut that risk and just switch everything out. Make sure that all your cryptographic algorithms are up to date. So, for example, you don't want to be using the SHA-1 hashing algorithm because, well, I've just read that it's not secure anymore. So go over all your algorithms. I don't know what algorithms you might be using, but for example, in my application, I'm using some ECDSA curves. So I looked into which curves would be the most appropriate to use. I'm also using I need a hashing algorithm. So I knew not to use SHA-1 because that's what I found from my research. So I'm using a SHA-256 hashing algorithm. There might be other algorithms that you're using. I'm using bcrypt to hash some passwords. I've looked into bcrypt. Seems to be an up-to-date, accepted cryptographic algorithm. So, find out what the general consensus and what experts are saying and make sure that all algorithms using are up to date. Because even if you think that, your keys are all rotated, everything's properly authenticated and authorized, well, if you're building on top of a faulty cryptographic algorithm, that might just all be smoke. So now, next, ensure the physical integrity of all of your keys. If you have cryptographic secrets, you need to know exactly where they are. Not only that, you need to be able to access them. So if you're storing, let's say you have a safe in your office or a safety deposit box somewhere, you're storing things on a hard drive or a USB, that's, corruptible hardware. It could break at any time. So you want to make sure that you have actual physical access to the keys, that you can read the keys off of those devices. You should probably also consider having multiple physical locations for each key. So if your keys are all stored, on someone's laptop, well, if their laptop gets ruined, then it's over. So, if the safe gets robbed, if the office burns down, it's over. So you want multiple physical locations. You probably want to combine, a physical location that you have direct control over, and maybe consider some kind of cloud storage for these keys. So you have multiple physical locations plus, different hardware, and you know what I mean there. Just kind of, you want it to be varied. You want to diversify. That's the word. And yep, you need to know where they are. So, okay, then you want to review the organizational access control policies. So this is kind of the permissions, the authorization. You need to decide who has access to what data. Make sure password lengths are appropriate. Like a 3 or 4 letter password is just not very secure, because if the hash of the password gets out, it's going to be very easy to brute force the password. I recommend at least 10 characters in length for your passwords to ensure that they can't be brute forced easily. Password lifetime. So that's essentially what we talked about with rotating the keys. Who has access to the secrets? So not only, I guess I've been talking about you like as in one person, but there are going to be multiple people who might have access to the secrets. So we need to make sure that those people are trustworthy and that those people are acting in a manner that's secure. Their screens need to be locked. They shouldn't just be leaving their laptop open or maybe even accessible in public places, common sense things like that. We already talked about password sharing and things like that. Also, once you do have the data, you need to think about the appropriate channels for sharing the data. So some sensitive data should not be shared through email or through Slack or just thrown into, like Google Sheets or things like that. There's privacy policies. For those websites, you have your own privacy policy and commitments to your users. You need to be careful about the way that you're sharing sensitive data. Once it leaves your system, especially under GDPR, you can't just have your data going from one system to another without having certain agreements in place. Next, essentially just make sure that all of your authorization is up to date. So if people leave the company or the project, you need to make sure that you revoke their access. It's just kind of common sense. It makes sense to every quarter, just in case if you've forgotten to update that. Next, sanitize your data. So essentially, you should know exactly where all of your sensitive data is stored. And really, you should only keep sensitive data that you have to keep for no longer than absolutely necessary. Sensitive data is a liability. If you lose it, there are going to be potentially huge consequences. So why would you keep it around for longer than you need to? It's dangerous. So you should put policies in place, put automated processes in place that will sanitize your data. Essentially just delete it completely once you don't need it anymore. Next, you should really be reviewing compliance with regulations. So I've been just saying sensitive data as a blanket term, but it's going to depend on your jurisdiction, the jurisdictions of your users, and what type of data that you're storing. You need to find out for your application what sensitive data actually is. Some data you're not even allowed to store. For example, in the United States, if you're storing credit card, and it might be another place too, if you're storing credit card information, you can't store credit card information unless you follow the rigid PCI compliance rules. You can't store health information unless you follow the rigid HIPAA rules. You can't even store essentially any personally identifying information or just personal information. If you're somehow affiliated with the European Union or other European nations, unless you're following the stringent requirements of GDPR. So find out which regulatory concerns that or requirements you might have. And finally, the second to last thing is ensure proper logging and monitoring. You want to know when there's a breach or attack and be able to respond appropriately, be able to tell your users if you are required to, or be able to block certain IP addresses or somehow respond to the attack. And now the final thing is to make sure that you actually audit this audit. So you want to study up on the latest security practices. Make sure that make sure that the audit is up to date and is going to lead essentially to sufficient security. So that is the security audit in a nutshell. Hopefully that's useful to somebody. And if you have any questions, just let me know.